Hey everybody, and welcome to the screencast on applications of negative exponents. So at the beginning of it all, what we're going to do is quickly review some of the elements that we saw last week or in the previous video, which would look at sort of the reasoning behind what a negative exponent is and why it works. Okay, so part of our work, as you have in your notes, involved establishing the understanding of the rule, okay, through the use of patterning. So have a look at this sheet, this slide here, and as you notice, moving down the slide, as you subtract 1 from each of the powers, okay, so you can see the powers being reduced by 1 each time, we are dividing by 2 in moving down the slide from one power to the next. So you can see that there is a division by 2, or which is also a multiplication by half, all the way through from term to term. And we also saw that happening in our tables of values, which is really what this is. So by following the patterning, okay, the pattern tells us or suggests that 2 to the minus 1 is equal to 1/2. Okay, which is also, if we use the exponent, 1 over 2 to the 1. Another example of that, if we just go off to the side, if we continue the pattern, we reduced the exponent by 1 and made it minus 2, then by the rule that's there, or the patterning, that would be another half of a half, that's 1/4. 1/4 is also 1 over 2, 1 over 2 to the 2. So from that, we can see that 2 to the minus 2 is also equal to 1 over 2 to the 2. And so on with many, many examples. So with those many examples comes the understanding that a to the m, so that's any power raised to a negative exponent, is 1 over a to the m. Okay, so it's more or less flipping or finding the reciprocal of the power, and then changing the exponent to a positive. So in general, okay, so you're going to change the power by doing the following. Okay, so you're going to find the reciprocal of a to the minus m, and that is 1 over a to the minus m. And that's what it means to reciprocate, is to make a fraction with the numerator equal to 1. And then, after that, you're going to change the sign of the exponent. So that means that you're going to then write it as 1 over a to the m. So it's a two-step process. So step 1, find the reciprocal, and step 2, change the sign of the exponent. Now there are other ways to look at this too. So what I'm going to do is just clone the page so that we have that as a record. So clone the page, and it's taking a little bit of time. There it is. So then what we'll do, I'm just going to clear the ink from that, and then put this away, and then we'll look at a couple of other representations. Okay. So the second one we saw, so this is very quick, too much time doing this, but this one involves starting out with the same expression, which is 2 to the 2 over 2 to the 3. Okay. And then working it out in 2 different ways. So this would be the first method, or method 1, and method 2 is here. So notice how 2 to the 2 gets expanded in the 2 by 2, and then 2 to the 3 in the 2 by 2 by 2. Question came up from one of the members in our class, and they asked about, what is this crossing out of things? Okay, so that's referred to as canceling, or the canceling of like factors. Okay, so they also ask, well, why does that work? How does it make sense? Well, my question to them was, would you be okay in expressing this, and I add a 1 onto this because it doesn't change the meaning, would you be okay in breaking it up like this? And they said, and I quote, yes. Now I've got the highlighter selected here. I'm going to change that up. Here we go, to 1 over 2. And they said, yes, I'm okay with that. And from that, we were able to see that it's the same as what we started with. Because when you multiply fractions together, you would multiply the tops together to give you this, and then you would multiply the bottoms together to give you that. Okay. And then we also looked at the following. We're going to do a change here. There we go. So then I asked them, well, would you be okay in saying this? That 2 over 2, that's equal to 1, or it reduces to 1 over 1. And would you be okay with this in lowest terms? And they're like, yeah, absolutely. So the result of all of that is what you're left over with is 1/2. So this is equal to 1/2, which is what we have over here. So that's the reason why expanding the powers out into their factors and canceling or dividing out the like factors is works and is a great strategy to use when you're simplifying expressions involving fractions. So that's besides the point now, but the proof continues with the second point, which is down here. In using a previously established exponent law, which is the division rule. And the division rule told us that we need to subtract the exponents on our powers. So that leaves us with 2 to the minus 1. Okay. So in conclusion, because we began with the same expressions, and that's these right here in this column, we began with these ones, and they are identical. They produce 2 different answers, so therefore, those 2 different answers have to be equal to each other. So that's another reason why the negative exponents produce the fraction that's the reciprocal of the power with the exponent changed to a positive. Right? And this is 1 over 2 to the 1. That's a positive 1. So that's exactly why it works out. So in general, I'm just going to bring this down into place here. So in general, this might be a little hard to see. I'll leave that up at the top so it's much more clear to read. So these are the rules for negative exponents. So again, take the reciprocal, drop the power into the denominator, change the exponent from a negative to positive. Okay? Vice versa, if you are already given the fraction, okay, take that fraction, okay, take the power, and write it as such with a positive exponent. Okay, so take the reciprocal of a fraction and then change the sign. So it's the same thing. Okay. So what we'll do now is let's apply this to a few examples. So we'll see if we can split this into a couple of screencasts because they tend to get a little bit lengthy. So here's a quick one. All right. So let's apply our understanding of the negative exponent. So this one says evaluate, express as whole numbers or fractions. So let's start up here with 10 to the power of 3. So 10 cubed is none other than 1,000. So 10 by 10 by 10. And then 10 to the minus 3, not using my calculator, I'm going to use the new rule. So find the reciprocal and change the sign of the exponent to a positive. We know that 10 cubed is 1,000. So that's the same as 1 over 1,000. Part B, on the other hand, if we take minus 3 to the 3, okay, that's equal to negative 27. Okay. So please recall that the 3 as the exponent means that we're multiplying minus 3 by itself 3 times. And remember as well that when you have an odd number of exponents under multiplication, you get a negative. And 3 3's under multiplication, they, wrong number, minus 27. So let's have a look at the next part. Notice the exponent's a little bit different here. Okay, and that's to emphasize the point that in this one, because the exponent is even, and you have a negative base, -3, what that's going to mean is the result of that is going to be a positive value. So let's give that one a roll as well. So -3, and in fact, we're going to add on a part to this in just a moment. So -3 to the 4, that would be the same as the previous answer we had, which is -27, times another 3. Okay, so that would give us times another -3, which gives us a positive 81. Now, what if it had been -3 to the -4? Well, under the new regime or the new rule, you have 1 over, take the base, make a fraction out of it, change the sign of the exponent, and we've already evaluated -3 to the 4, so that's 1 over 81. So there's a quick application of the definition for negative exponents. Now, here's another one. This involves a little bit of algebra. Okay, so we're going to do some substitutions and use some exponent laws. We're going to write this expression as a power with a single base of 3. So what it means to have a single base is that the answer is going to be 3 to the whatever. Okay, there's not going to be any other operations or any other numbers involved. So let's go ahead and do that. So first we need to substitute. So my x is 3 to the 3. So wherever there's an x, I'm going to substitute in 3 to the 3, and keep what was already there as part of the initial structure of the expression. The y, on the other hand, is 3 squared. So what we'll do there is we're going to substitute in, multiply by 3 squared, and here in the bottom, it's multiplied by 3 squared to the -1. So moving forward, we apply our rules. Okay, so on top, you can see that we have multiplication. So that means that these two values will end up getting multiplied together to produce 3 to, my apologies there, where that's an addition. Thinking of a power to a power. So that's an addition piece. I'm glad I got that. So we're going to add those together. It's down here in the bottom, like power to a power, where we'll multiply these together. So let's set that up. So in the top one, 3 to the 5. In the bottom, we have 3 to the 6 being multiplied by 3 to the -2. So moving that forward, keep the top, keep working in the bottom. We're multiplying, so we're going to add those exponents together. So that would be 6 plus -2. Up here to the top right. So that's 3 to the 5 over 3 to the 4. Last but not least, we have two options here for solving it. Okay, and I'm going to do this in a different way just to emphasize the point, but we can do the following way. We could subtract in a different direction. So if I were to subtract by taking the 5 from the 4, okay, that forces us to use the negative exponent rule. So this would become 1 over 3 to the -1. But according to one of the rules prior to that, to get it as a positive exponent, you would reciprocate or flip it and change the sign of the exponent. So the answer is just a 3. Alternatively, we could have done that differently. We could have said that's equal to 3 to the 5 minus 4. So none other than 3 to the 1 or 3. So there's a couple more examples to follow this up, but what we'll do, let's split this into two screencasts. Okay, so part 1 followed by a part 2.